Hi everyone. Now we are going to discuss about rearrangement in carbocations. The first part we did some examples, clear concept I explained. First of all, you watch that one, and some more examples are there. So that's why we'll do now part 2. Right? Let's start now. Here, there 4 examples I gave with the different examples. Now fifth one, continuation in the part 2. We'll take one example here. CH3, CH2, CH2 plus. And here isopropyl group is bonded, and here ethyl group is bonded. Right? This is a ethyl group CH2, CH3, and this is a CH3. This is a methyl group, and this one is a isopropyl group. Right? Now this carbon is positive charge, it is unstable, it is crying. Then adjacent carbon, it is having ethyl group, methyl group and isopropyl group. Which group migration will take place? That is the deciding factor. That is here, the group which gives more stable transitional state, that one migration will happen because that gives more electron density. How? See, for example, here in this case, if this isopropyl group CH, CH3, CH3, CH3 taken twice group is called isopropyl group. If this isopropyl group is migrated, okay, then what I mean, first of all, take a transitional state, you get the concept clearly. So here carbon and here methyl group, this is, and here ethyl group is there, and now this is CH2. Then transition state, this migrated and make a bond with this. You have to just represent a partial bonds, that is a transitional state. Okay. So now here carbon and here methyl group is there. This carbon carrying positive charge, right? Because not complete bonding is formed, not permanently. So temporary bonds are there, partial bonds are there, right? Now, so then here this carbon is getting electron from this. This is a methyl group, it is also methyl group. You know, methyl groups, these methyl groups are electron releasing groups. So these two groups are electron releasing groups. There is plus side groups, positive inductive groups, right? So that's why they releases electrons, right? That increases electron density. So which increases electron density, then the formed transitional state is more stable. That means the transitional state is getting more stable if isopropyl group is migration takes place. Is it clear? Than ethyl and methyl group shifting. Now, so more the stability of transition state is more, greater the stability of transition state, faster the reaction takes place, because from the greater the stability of transition state, you will get more stable intermediate. From that, you will get more stable product, and also faster the reaction takes place. So that's why. So what happens is here. So this bond is break up, then it is completely make a bond. So it break up, and okay, this bond is completely break up, and this bond is completely make up. You will get a permanent bond is formed here, not partial bonds, right? Then you will get the product is like this here. So this is a ethyl group, and this is a methyl group. And here this is isopropyl group. You just represent or here also or maybe here also. Okay. So this is isopropyl group. Right? Got it? This one, this group, this one. This is isopropyl group. Then this carbon gets positive charge. This is a isopropyl group. Is it clear? Okay. That is. Then this is a more stable. It is bonded this side with one, this side with one, this side with one, 3 carbon. That is it is bond 3 more carbons. It is a tertiary carbocation, and this is a more stable carbocation, right? But here what is there? A primary carbocation is there. This formed primary carbocation is stabilized. It is less stable, my dear student. It is less stable. This less stable carbocation is converted into more stable tertiary carbocation. Is it clear, every one of you? Now, one more thing, one more example, one small change will be here. See, 3 carbons, 1, 2, 3, and here CH2 plus carrying positive charge. Yeah, it is primary. Yeah. Then what you will get? This is ethyl group is there. Yeah, it is ethyl group, and this is a methyl group. And here, so previously what is there here? Isopropyl group. Now I am making one small change, that is methyl group. Now it is a tertiary butyl, right? It is a tertiary butyl group, right? It is a tertiary butyl group, T-butyl, right? This thing is tertiary butyl. This is a methyl group. This is a ethyl group. So now, to stabilize this primary carbocation, methyl shifting, ethyl shifting, or tertiary butyl shifting, which is possible. The deciding factor is which produces more stable transition state, that will give more stable products. So that's why the first of the reaction is take place. So that will migration, that group will migrate. Yeah, is it clear? Right. So here, if tertiary butyl is migrated, yeah, if this group is migrated, then what will get the transition state? Here 1, 2, 3. Here it is CH2. Yeah, and here ethyl group is there, and this is the methyl group. Okay, and then this tertiary butyl group is shifted here. Okay, this group. Yeah, this group. This is shifted here. This group. Okay, this one. Yeah, shifting is happening. Yeah. So this group is shifted, right? Then what you get here, carbon, and here 3 methyl groups are there. So these are all. So it is there is complete bonding is not take place, right? I just represent now a transition state for your understanding here. So this is from here. It is migrated here. Partial bonds. Okay. Then this is bonding with 3 sides are there. That is methyl groups are there. Now this is positive charge. This is a transitional state. Yeah. So then this the electron density of this is increased by 3 electron releasing groups are there. So these are all good friends. They are releasing electrons. These are all plus I groups. So that's why they, by releasing electrons, they increase electron density. Then because of that, you will get the transition state is more stable. From a more stable transitional state, you will get more stable product and faster the reaction. So that's why that is rather than stable, more stable product you will get. Yeah. So that's why rather than methyl group and ethyl group shifting, then tertiary butyl group is shifting is take place. Or if maybe if they will give here one more. Now it is what? Isopropyl group. Yeah, isopropyl group. Now which is shifted here? Methyl is there, isopropyl is there, isopropyl. I-pro indicates what? That is isopropyl group, right? Okay, and I will make it here isopropyl group, right? So in this case also, if isopropyl group is there, methyl group is there, and tertiary butyl group is there, shifting of tertiary butyl group is take place, because in having 3 methyl groups are there, that will increase the electron density. So that's why after that the transition is more stable. From that, after some time here, this carbon, this bond is completely break up, and this bond is completely make up. We'll get a permanent bond. Then we'll get more stable carbocation. It is isopropyl, and here this bond is break up, and you will get here. That means you just make it here this one. So then this is carbon, and here this is bonded with alkyl groups, 3 alkyl groups, right? That means this one I just represent this one here. Okay, yeah. So then what about this carbon gets positive charge? It is a tertiary carbocation. It is a tertiary carbocation. It is a more stable carbocation. Here we are here, a primary carbocation is there. So it is converted into more stable tertiary carbocation due to 1,2 butyl shift is take place. Okay, there is a tertiary butyl. 1,2 tertiary butyl shift is take place. Shifting of the tertiary butyl group. Is it clear? Okay, shifting of the tertiary butyl group. And in this case, here who is shifted here? 1,2 isopropyl group. 1 comma 2 isopropyl group shifting is take place. Is it clear? Okay, yeah, got it? Fine now. Copy it, my dear students. Every one of you copy it. Yeah, next one. Next one. From these concepts, frequently questions are appearing because then students are committing a mistake by giving, that is they didn't get properly, that is okay, migration of methyl shift or ethyl shift or hydrogen shift is happening. Suddenly maybe in tension they commit a mistake. So that's why, so wherever the students are committing a mistake chance, there they frame the questions, you have to alert it. Okay, keep in your mind wherever carbocation is found, then keep in your mind, oh, I have to check it once, maybe shifting is happening or not. From that, after shifting, we'll get the major product. So this you have to take care. Yeah, now let's talk one more example we'll do now. So this is a all-time favorite example. That is, see here carbon, okay, and here carbon, it is a current positive charge, and here methyl group is there, and here hydrogen atom is there, okay, and here phenyl group is there, phenyl group, yeah, phenyl group is there, yeah. So three groups are there, okay. Shifting of which one is take place, okay. Shifting of which one is happening, that is right. Yeah, now we'll do now. So here, which will give more stable product, that is take place. There is one deciding factor, right? Yeah. Now check it here. This one, the migratory aptitude. Maybe migratory aptitude means I'll give you order, right? Speed of the shift. That is depends on electron density. Yeah, right. So if hydrate shift is take place, then what you'll get? You get like this. There is 1 comma 2 hydrate shift. 1 comma 2 hydrate shift. Okay. You'll get like this. There is CH3. Okay. Yeah. CH3. And here carbon. And here phenyl group is there. Yeah. Okay. And here CH2. And CH2 become into what? CH3. Because this hydrogen is bonded here now. So 2 become into 3. Right? Yeah. Then this carbon gets positive, right? Okay. Then next one, if this methyl group shifting is take place, then what will get? If methyl group shifted, these two electrons it will take and it make it bond disconnected with this shifting of methyl group. Shifting of 1 comma 2 methyl shift, 1 comma 2 methyl shift. So because of that, what you will get? You will get, there is here carbon, here hydrogen is there, and here it is bonded to, that is phenyl group is bonded, yeah, and then here CH2 to this methyl group is shifted, that is CH3. Is it correct? Right? Yeah. Okay, right? Yeah, this one, yeah, right? Okay. Now, so then this carbon, yeah, this carbon. So this is CH2. Okay. Now it is getting, then this carbon gets positive charge, this one. Yeah. Right. This carbon, because it's split, right? This carbon. Right. Next. If phenyl shifting is take place, 1 comma 2 phenyl shift. Phenyl group, C6H5. Phenyl group is shifting. Shifting of the phenyl group. The first one is a hydrate shift, 1 comma 2 hydrate shift. Second one is 1 comma 2 methyl shift. Then the third one is a phenyl shift. If this phenyl group, okay, will shifted, then what you will get? That is 1 comma 2 phenyl shift. You will get like this. There is CH3, okay, here carbon and here hydrogen, and here what is there? CH2, okay, and this phenyl group is bonded to this one. Yeah. Right. Fine. Okay. Yeah. Now, So this carbon gets positive charge. Is it clear? Right. Then which will happening? For that different factors we will discuss now. But here in this case, if 1, 2 hydride shifting is happen, what you will get here? This carbocation. This one, this side with one, this side with one, this side with one. So it is a, it is a tertiary carbocation. Yeah. Then here this is bonded this side with one and this side with one. It is a secondary carbocation. Yeah. And here this is one, this side with one, this side with one. You get a secondary carbocation. Yeah. So that's why it is happening. That too here, hydrogen is smaller in size, right? This is smaller in size. So that's why it is readily migrate. Shifting is because the smaller size readily migrated. As bulkiness increases, shifting, okay, attacking is somewhat difficult, right? Okay, bulkiness of the roots, hindrance, okay. So that's why, because the smaller size, migratory speed is more for H minus hydrogen, okay. That too, what are the factors here? So we can discuss the factors are also why it is tertiary is more stable here. See, look here, in this case here, this is the carbocation adjacent carbon is alpha. Here 3 alpha hydrogens are there, it is alpha, okay. So totally here also 3 are there. So totally we are getting now 6 alpha hydrogen atoms. So 6 alpha hydrogens are there means 6 alpha hydrogen atoms are there means you will get hyperconjugation effect is take place, hyperconjugation effect, you will get 6 hyperconjugated structures, right? 6 hyperconjugated structures it will give, right? That means, so we can represent for our convenience like this, for our easy understanding. So this is CH3. Okay, the CH sigma 1 electrons are in conjugation to the positively charged carbon of empty vacant p orbital, right? So they migrate, they make a bond here. This is stabilized, and here also, and it may also you will get 3, and here also that is CH3 means you will get like this, right? That is CH3. So this sigma electrons are migrated here and make a bond here and they make a bond here like that. You get 6 hyperconjugated structures. It is going to be readily stabilized, and that too here. What is there here? See, this is double bonds, single bond, positive charge. Pi bond, sigma bond, positive charge. Wherever pi bond, sigma bond, positive charge is there, the entire characteristic conjugation is there, right? There resonance is take place, right? There is delocation of electrons is take place, right? This dispersal of charge is take place, right? There is resonance effect is take place, right? Yeah, that means now what I mean, these pi bond electrons are their delocalized and make a bond here is going stable on this carbocation, and this so it get positive, then it is migrated here, then it gets positive, then it is migrated over here like that. Totally how many structures here? Hyperconjugation is take place, and also resonance is take place. Fine. Okay, both hyperconjugation and resonance. Okay. Hyperconjugation and resonance both are take place, right? Is it clear? But what about here? This carbon, this adjacent alpha, how many alpha hydrogens are there? 2 alpha hydrogens are there, right? These 2 alpha hydrogens are there here. Only 2 alpha hydrogens are there. You will get this forms that is 2 hyperconjugated structures, and this resonance effect is also happening here. Okay, so that means there is only 2 alpha hydrogens are there. So that's why you get 2 hyperconjugated structures. It forms. Okay, it results 2 hyperconjugated structures, right? Okay, so then and resonance is also take place here. Resonance is take place, but here 6 hyperconjugated structures. Okay, but here we are getting only 2 hyperconjugated structures. So then this one it is more stable. Is it clear? Right? Okay, number of hyperconjugated structures are greater here. Here only 2 are there here. Right? Number of hyperconjugated structures are greater here. Here only 2 are there. Is it okay? Got it? What about here? In this case, here alpha is there, alpha hydrogens are there. How many are there? 3 alpha hydrogens are there. Okay, so it forms 3 hyperconjugated structures you will get, and here resonance is not take place here. There is no resonance. Okay, no resonance. Okay. Resonance is not take place. So that's why only hyperconjugation, right? As you know, the order of stability is resonance stabilizing product is more stable than hyperconjugation, right? So that's why there is the order of stability is influenced by first resonance stability will give more stable the carbocation than hyperconjugation. Okay, so resonance stabilized one is first one, next then hyperconjugation. So that's why, so here no resonance. No resonance means, so compare this one, it is more stable. Compare this one, it is more stable. Then, so that means the shifting of which one is give more stable products. Yeah, this one. This is the, we'll get tertiary, here secondary, here resonance, hyperconjugate structures, six hyperconjugate structures and resonance. Here 2 and resonance. Here no resonance, only hyperconjugation. That's why that is the order of this migratory speed. Okay, got it. Okay, so the speed of shift. Okay, got it. It is called as migratory aptitude. Migratory aptitude. Migratory aptitude. Okay, there is nothing but what? Speed of the shift. We can call it as speed of the shifting, right? Migratory aptitude is nothing but speed of the shift. It is directly proportional to what? Electron density. Here it is getting more electron density. Yeah, so it is directly proportional to electron density. Okay, then it is readily stabilized. Okay, that's why migratory aptitude of which group is happening first. That is hydrate shift. The order of migratory aptitude. The order of migratory aptitude is first one hydrate shift, and the next one is what? That is alkyl shift. That is alkyl shift. Okay. So what is there here? Phenyl shift. This is phenyl. This is what? Alkyl shift, and here this is phenyl shift. Okay. But if methyl shift and alkyl shift and phenyl shift is there, so phenyl shift is gives more stability. Which one? Next up, I'll explain now. Next one is alkyl shift. Alkyl shift. Yeah. The alkyl shift. What is the highest one? Is tertiary. Okay. There is a tertiary butyl group. Okay. Next one is secondary. Next one is primary. That is tertiary butyl group is CH3 taken twice C. Okay, and this group. Next one is CH isopropyl. That is CH3 taken twice CH group. Okay. Next one is there is ethyl group. There is CH3 CH2. This is a primary. Okay, CH3 CH2. Okay. Next one is methyl shift. Methyl shift. Is it clear? Okay. Okay. Yeah. So this is the order of migratory aptitude. Migratory aptitude, that is a tertiary butyl group, right? Okay, is it clear? Right, this one you have to keep in our mind. There is a trick I am giving to you. Okay, Kim means what? Keep in our mind. Then it is very easy to do it. So that is this one you have to just keep in our mind, my dear student. What is that? That is first hydrate shift. Next is greater than. Next phenyl shift is greater than alkyl shift. In alkyl shift, tertiary butyl. Next second isopropyl or secondary propyl. Next ethyl. Next methyl. Is it clear? 3 to 1. 321. The shifting is order is 321. That is 321. Is it clear? Next here HOPHOR. HOPHOR. Hydrate shift to phenyl shift to alkyl shift. Is it clear? Right? Yeah. You can enjoy this one. So regarding rearrangement of carbocations, all concepts I completed. Enjoy my video, right? Okay, like it, subscribe it, and share to your friends. They will also get benefited. So we are doing so much effort to give to you easy way to understand. So that's why. So you just like it and subscribe it. Okay, subscription is that will motivate us to do some more videos. Thanks for watching my video. Fine.